Hey y'all, in this video I'm going to introduce you to my new rotary axis kit, which is going to be an absolutely fantastic addition to my Gatton CNC. So let's not spend a lot of time BSing, let's get in for a close-up. Let's take a closer look at the kit itself. This is the Sunwin Model 073 100 millimeter rotary axis kit. And it's almost, but not quite, absolutely nothing like what came out of the box. And I'll get into that in a little bit here. What did come in the box is the headstock unit, the tailstock unit, an extra set of jaws that are machined for clamping things internally versus the jaws on here, which are meant to clamp around objects externally. More on that later on. And it also came with the chuck key, of course. The tailstock unit, when I ordered this, I had my choice of 3 different centers here. I could get a standard pointed dead center, which I did not want. They call that a Type A dead center. Then I could get the Type B, which was a live center like this one, which means this portion here spins on the bearing, but it had a flat nose on it. I didn't want that either. So I chose this one. This was considered, according to them, a Type C tailstock that has the live center that comes to a point, because about 95% of what I'm going to be turning is also is going to be done between centers. Now, on the headstock unit itself, it comes with the 4-jaw scroll type chuck, which means that when you insert the chuck key and turn it, all 4 jaws move at once. Some folks like those, some folks don't. It is a 100 millimeter chuck, meaning that it'll open up to just shy of 4 inches, 3.97, I want to say, something to that effect. And it is a hollow spindle, meaning that the spindle that connects this drive pulley here to the faceplate and therefore the chuck is hollow. I can put a workpiece inside the jaws and slip it back in here somewhere if it happens to be a little bit too long. That was, there's a few things that I plan on milling that would be a benefit, so I went ahead and went for this one. Now, I know that there are less expensive units out there. I chose this one for 2 big reasons. Number one, ordering from Amazon, I knew if I got a defective unit, it would be easier to return it than if I went with another supplier from eBay or something like that. Number 2, when I ordered this unit, they were offering free shipping, and that was a big decider too. Now, there are less expensive units out there, like I said, but just forewarned is forearmed. I found a unit that was similar to this. It was solid spindle, though, and it came with a 100 millimeter scroll type 4-jaw chuck on it, and it was $150 until you looked at the fine print. Shipping to the United States was $195. So more than the cost of the unit itself, and it would have made it more expensive than what I paid for this anyway. So that's why I chose the unit that I chose. Now, when I said this is almost, but not quite exactly, nothing like how it came out of the box, there are a few things that I had to change out. One of them I knew off the bat that I was going to have to change out, and that was the stepper motor. This is not the stepper motor that came with the unit. This is. This is a 3 amp, I believe this one is 269 inch ounce. I could be wrong on that, but the important thing is it is a 3 amp motor. I'm using the Xylotex drive box, and the Xylotex drive box is a 4 amp system. So I knew going in that I was not going to be able to use this motor. But I figured, okay, fine, I can take this motor off. It's a NEMA 23 frame. The Xylotex motor is a NEMA 23 frame. It'll bolt right up. And it did. And I already had this Xylotex motor as a spare I was going to use for another project. Swapped out the motor and everything was fine until it came time to take this little timing pulley off of this motor and put it on the Xylotex motor. For those of you who know Xylotex, you know that they come with a 1/4 inch motor shaft. This little motor came with a 8mm motor shaft. So yeah, this pulley would not work. Now I know some of you machinists out there are saying, well, that's very simple. You just, turn yourself a sleeve, plug it and turn it out, make yourself a sleeve for it, and it'll work just fine. Well, that's great if you're a machinist and you have a metal lathe. I don't, and I'm not. So this went out the window along with the pulley. I then had to look for and find a timing pulley that would fit the 1/4 inch shaft and a 5mm pitch belt 15 millimeters wide. And that was more difficult than I thought it would ever be. And I finally came up with this little puppy right here. That's the correct timing belt, the correct belt pitch for the correct width of belt. And it wasn't expensive. I ordered 2 because I know if there's a way I could mess one up, I would. And the pair of them were $9.95. It was not a big deal. I normally don't give out prices, but I did that time just to let you know that this is not a deal breaker. Then the next problem that came about once that timing pulley finally got here was the belt. You see, the Xylotex motor is not only higher amperage, it's physically longer than this motor by about 1/2 inch. So when I got the correct pulley mounted on the Xylotex motor and got it mounted to the frame, got it lined up and everything was just perfect, these Allen bolts that hold the chuck to the faceplate hit the motor right here, and the system wouldn't turn. It would not move. And I could not tension the belt far enough out. So the 350mm belt that came with the unit was absolutely worthless to me. So I got online, looked again, and I found a 355mm belt and a 360mm belt. Now, I know my luck. If I would have ordered the 355mm belt, it would have been too short. And if I'd have ordered the 360mm belt, it would have been too long. So I ordered both. No big deal, a couple of dollars a piece. Links in the description box below for everything that I'm talking about here, and everything that I've mentioned. So with the correct pulley finally on the motor, the correct belt that would allow me to tension it far enough out, I thought I was golden. Then I got to looking at it. I'm going to throw a still shot up here of the way this is configured straight out of the box. And if you'll notice, it's kind of a mirror image. See, from the factory, the stepper motor is mounted on this side of the unit. And that wouldn't help me any. This is going to be mounted permanently, or semi-permanently, down in the cutout in the front of my CNC machine. That's why I put it there, that cutout. And the motor being on this side would have pushed the whole unit out this far, which would not allow me to use the mount that I plan on using for this. So I went ahead and I pulled the motor off again, pulled the belt off. I then removed this pulley here, which came off very easily, and there are 4 bolts down inside, one here, and one here, and one here, that you have to remove this pulley to be able to access. With those removed, I was then able to simply pull those screws, flip this over to this side, mount it back on, put everything back together, And there you have the unit as it is right now. Now that sounds fairly easy, and it is fairly easy. It wasn't much to do. After that, all I needed to do was do my settings in Mach 3, come out here, plug it in, and give it a shot. And it works. So, I'm going to put links in the description box to everything that I've discussed, the rotary axis kit itself. I'll leave a link to Xylotex where you can order a motor to use it with the Xylotex drive box. I'll leave a link to where I got the timing pulley and where I got the other timing belts. So that's it for this video, the introduction of my rotary axis for my Gatton CNC. Now, if you got anything at all out of this video, please click that thumbs up button down there. I really do appreciate it. If you want to follow along in my CNC adventure, hit that subscribe button down below, then click that little bell right next to it. That way you'll get a notification when I post the next video in this series. Speaking of the next video, in the next video what I'll do is I'll get into Mach 3, show you how I created a new profile for the CNC, then the settings that I use to make this work with my Xylotex drive box. But that's in the next video. Now if you have any questions about anything I've covered in this video, go ahead and leave them in the comments section. But please remember, I've got at least one more video coming up, so more will be revealed then. Okay? So, also know that I've posted an article over on my website, marklindsaycnc.com, which is sponsored by Harneal Media, who does an excellent job. So, again, thank you very much for watching, and y'all take care.